Most gold nuggets are found in silence. A prospector swings a pick into dry gravel, a detector hums over ancient river sediment. Somewhere beneath the dust sits a lump of metal that has waited millions of years to be touched by another living thing. But deep in the Amazon rainforest, one gold nugget was discovered in a place that looked less like prospecting and more like the collapse of civilization itself. In the early 1980s, tens of thousands of men descended into a giant open wound carved into the jungle of northern Brazil. From above, it looked almost unreal. Endless lines of human figures climbed muddy ladders carrying sacks of earth on their backs like ants inside a collapsing crater. The walls were slick clay. People slipped constantly. Some died in landslides. Others vanished into the chaos. And somewhere inside that enormous pit, hidden beneath tropical mud and oxidized rock, lay the largest surviving gold nugget on Earth, the Pepita Canaã. Today, the nugget weighs 60.8 kilograms. Of that, more than 52 kilograms, or 114 pounds, is pure gold. It is the largest natural gold nugget still physically existing anywhere in the world. Unlike most gold nuggets from the great gold rushes, it was never melted down. It survived. And that alone makes it extraordinary. But despite its fame, the Pepita Canaã is often misunderstood, because technically it was not the largest gold nugget ever discovered. That title still belongs to Australia's legendary Victorian gold rush giant, the Welcome Stranger, uncovered near Moliagul in Victoria in 1869. The Welcome Stranger was vastly larger, weighing an estimated 109 kilograms before it was broken apart and smelted. Had it survived intact, it would tower over the Pepita Canaã today as the undisputed king of all nuggets. But it did not survive. And that difference changes everything. Because the Pepita Canaã is not just a historical measurement written in old newspapers. It is still here, still visible and still real. You can stand in front of it and see the distorted shape of natural gold that formed somewhere deep inside Earth long before humans existed. And the geology behind it may be even stranger than the nugget itself. The Pepita Canaã was discovered in 1983 at Serra Pelada, one of the most chaotic gold rushes in modern history. Word spread rapidly across Brazil, and within months the rainforest exploded into a frenzy of illegal mining activity. At its peak, more than 80,000 garimpeiros flooded into the area. Unlike Australian goldfields filled with dry bushland and shallow alluvial leads, Serra Pelada was tropical, humid, unstable and violent. The pit became a gigantic hand-dug amphitheatre, descending into red and yellow clay. There were no haul trucks in the early days, no giant excavators. Men carried everything by hand. And beneath them sat one of the richest near-surface gold accumulations ever discovered. But Serra Pelada was not a simple placer deposit. This is where the geology becomes fascinating. The gold originally formed as a hard rock hydrothermal system inside the ancient rocks of the Amazonian craton. This craton is one of the oldest surviving pieces of continental crust on Earth, containing Archean rocks more than 2.5 billion years old. Deep underground, hydrothermal fluids once moved through fractures and brecciated zones, depositing gold alongside sulfides and quartz. In a normal hard rock system, much of that gold would remain locked inside veins and sulfide minerals. But Serra Pelada spent millions of years under intense tropical weathering, and tropical weathering changes everything. The rainforest climate slowly destroyed the original rocks from the top downward. Sulfides oxidized, minerals decomposed into clay-rich saprolite, iron concentrated into rusty lateritic zones. Groundwater circulated constantly through the weathered profile. Over immense spans of time, the original hydrothermal deposit became chemically transformed into something else entirely. Instead of fresh rock, miners encountered soft oxidized earth. Instead of hard quartz reefs, they dug through clay. And somehow, inside that clay, enormous masses of gold survived. Some geologists believe the gold may have even grown larger during weathering. Under certain chemical conditions, tiny amounts of dissolved gold can migrate through groundwater and reprecipitate onto existing nuggets. Over geological time, this can potentially enlarge natural gold masses. The idea remains controversial, but Serra Pelada is one of the strongest examples used to support the theory because the nuggets found there were so unusually large and so concentrated within deeply weathered material. This is one of the major differences between Serra Pelada and the Australian goldfields. The Welcome Stranger was found in an ancient alluvial lead in Victoria. Its gold had eroded out of quartz reefs hosted within folded Paleozoic sedimentary rocks. Over time, rivers concentrated the dense gold into buried gravels beneath the surface. The nugget itself likely travelled only a relatively short distance before becoming trapped in clay-rich sediment near bedrock. The Pepita Canaã came from something far stranger. It formed from a hydrothermal hard rock system that was later chemically dismantled by tropical weathering until the original geology became almost unrecognisable. It existed somewhere between hard rock and residual enrichment, not fully reef gold, not fully alluvial, something transitional and uniquely tropical. And the conditions inside Serra Pelada were unlike anything Australia ever experienced. At the height of the rush, the mine resembled an enormous human hive. Tens of thousands of miners climbed unstable ladders carrying 30-kilogram sacks of sediment on their shoulders. The walls constantly collapsed, mud coated everything, armed guards controlled sections of the pit, disease spread rapidly. Yet despite the danger, people kept arriving because the gold was unbelievably rich. Photographs from the period barely look real. Entire hillsides appeared alive as rivers of people moved up and down the pit carrying ore. In some places, miners could literally see gold inside the clay walls. Nuggets the size of fists emerged from oxidized material with almost no modern machinery involved. And then came the Pepita Canaã. The nugget was reportedly found about 4 meters underground. During extraction, parts of the nugget may have broken away, meaning the original mass could have been even larger than the surviving specimen displayed today. That possibility has fueled speculation for decades. Could the original nugget have approached the size of the welcome stranger? Probably not, but nobody knows for certain how much gold may have detached during recovery. In a deposit already producing absurd quantities of coarse gold, the idea is not impossible. Yet, even without that speculation, the Pepita Canaã occupies a completely different category in geological history, because surviving gold nuggets are incredibly rare. Nearly all of the legendary nuggets from Australia's gold rush were destroyed. The welcome stranger was broken apart almost immediately because it was too large for the local scales. The welcome nugget was melted. The Lady Hotham vanished into bullion. Again and again, the world's greatest nuggets disappeared into furnaces because gold was treated purely as money. The Pepita Canaã escaped that fate, and because of that, it became something larger than a lump of precious metal. It became evidence. A physical reminder that natural geological systems are capable of producing concentrations of gold so extreme they almost seem impossible. Even today, Serra Pelada remains geologically mysterious. Some researchers classify it as a hydrothermal breccia deposit. Others emphasize supergene enrichment processes. Platinum group elements were also found there, which is highly unusual in many gold systems. The precise interplay between hydrothermal mineralization, tropical weathering, structural controls and secondary enrichment is still debated. But one thing is certain, the deposit was not normal. And perhaps that is why the story feels so different from Australia's gold rushes. The Victorian fields produced giant nuggets across broad landscapes of shallow alluvial mining. Prospectors wanted creek systems, gullies and buried leads beneath eucalyptus forests. The geology was ancient and folded, but the mining itself often remained decentralized. Serra Pelada was concentrated madness. One pit, one collapsing wound in a rainforest, and one of the richest gold discoveries of the 20th century. And at its center sat the largest surviving gold nugget on Earth. The strange part is that the Pepita Canaã almost looks incomplete. Unlike the smoother, rounded forms of some alluvial nuggets, it appears jagged and fractured, as though torn violently from the earth before the geological processes shaping it had truly finished. When people imagine giant gold nuggets, they often picture smooth golden boulders, but natural gold rarely behaves that way. It twists, compresses, fractures and recrystallizes into chaotic forms depending on the environment it experiences. The Pepita Canaã carries the scars of its geological history across its surface, and maybe that makes it more important than the welcome stranger in one specific way, because the welcome stranger survives mostly as measurements, sketches and historical descriptions. It belongs to history. The Pepita Canaã belongs to geology. It still exists as a real object scientists can examine, a surviving fragment of an ancient hydrothermal system transformed by millions of years of tropical alteration. A preserved example of how violently Earth can concentrate metals under the right conditions. And somewhere beneath the rainforest of the Amazonian craton, the remnants of that same mineral system still remain buried beneath oxidized clay and jungle soil. Which raises an uncomfortable possibility. If a hand-dug pit filled with thousands of desperate miners could uncover the largest surviving nugget on Earth using ladders, shovels and sacks, how many more still remain hidden in places nobody has truly explored yet? I hope you found this as interesting as I did, and as always, thanks for watching. Before I end this video, I'd like to give a big shout out to my Patreon and YouTube members. Thank you so much to everyone that helps to support this channel.